My name is Gautam Balakrishna. I am a data science trainer. In this section, we'll cover some of these topics. So the 4 V's of big data. What is business analytics, which you guys are pretty much aware of as part of your day-to-day activities, and what are the various business analytic applications, importance of business analytics, types of analytics. We will cover data analytics versus statistical analytics, business analytics, and what is a model, what is a decision model, how to use this decision model. So basically we will be kind of going through the overview of these features so that we are well set in the next few days to actually apply these concepts using R for our purpose. So that's pretty much. And then in the final sections, we will also cover the role of a data scientist. Of course, when you are in the business analytics area or in the data analytics area, getting into the data science domain is the most important thing from a career perspective for a lot of people. A lot of people like to just remain in the business analytics field, but data science, getting into the data science field using predictive models, forecasting, being able to forecast future trends and events, that is what ultimately the goal of any business analytics or data analytics person should be. So here they have discussed the four V's of big data. So basically, the 4 V's of big data, or data science domain, are like volume, velocity, variety, and veracity. So just to give you a much better understanding, I have some slides which I would like to share. I would like to show to you guys on the screen. So as part of my introduction to data science section. So in this section, I would like to cover the 4 V's. Before that, I want to kind of bring up some of the quotes by a few data scientists or computer scientists around the world. So basically, science is defined as knowledge which we understand very well, so which we can make the computer understand as well. So basically, what Don Knuth, computer scientist, is trying to say is that when we can make a computer understand whatever the aspects of data science that we understand, that is when we can get the maximum value of the domain of data science. So basically, whether it is in the form of using algorithms or whether it is in the form of using some kind of models, when we make these, when we make the computer understand these models, that's when we can get the maximum value out of this domain of data science. Similarly, John Stuart Mill, he is not from a data science background. He's a philosopher, English philosopher. So basically, he says that science groups and arranges its truths so as to enable us to take in at one view as much as possible of the general order of the universe. So basically, what he's trying to say is that what science does is that it groups and arranges information in a way that can be very easily understood by the human brain. So whereas information, when it is lying scattered around, it can be very confusing for us to understand. So when we can use science to group and arrange this information in a meaningful way, that's when human mind can make sense of it. That's where data visualization and data analytics comes into picture. So just to move further, let's try to understand what these 4 V's are that was discussed in the earlier example. So the 4 V's of data science are volume, velocity, variety, and veracity. So why these 4 aspects or 4 V's are very important for us? So that's what I want to discuss. So to discuss that, I want to make a statement here. As far as the statement is concerned, it says that since the dawn of time up until 2005, humans have created about 130 exabytes of data. So this statement says, humans have created 130 exabytes of data. So you will ask me, what has 130 exabytes of data anything to do with what I am going to learn here? So that is what I want to discuss here: the volume, velocity, variety, and veracity. I would like to explain through these slides. So just to say what this 130 exabytes is. So if you start with one letter, that is one alphabet in the English language. So if this one single alphabet has to be stored on a computer, so that equates to about 1 byte of space on your hard disk, right? So alphabet, if you have to store in using a notepad, or if you want to store this information on your computer, it's going to take about one byte of storage space. Now, if you translate that 1 byte into 1,000 times, if you multiply that by 1,000 times, so like a page of data, let's say in a novel or in a book, that would a single page of data that would have about 1,000 alphabets, 1,000 characters. And if you multiply 1 byte by 1,000 times, that would lead to about a kilobyte of information. So one page of data would result in creation of about 1 KB. So that is about 1 kilobyte, 1 KB of information. So if you zoom further to another 1,000 times, so a 1,000-page book, a novel, or any technical book that you study, that would probably on average have around 500 to 1,000 pages. And if you fill up these pages with all information, anyway, so if you, like I was telling you, if you zoom out another 1,000 times, that would be like a book, a novel. So a novel with about 500,000 pages, that would be about 1 MB. So we just multiplied 1 KB by 1,000 times, 1,024 times, and that is actually equivalent to 1 MB. So if you look at your most of your e-files or your e-books or things like that, a small e-book would be about 1 MB. So let's say if I zoom another 1,000 times from 1 MB to, let's say, another 1,000 times, now that would be like 1 gigabyte of information. So they say that if you take a human DNA or a human genome, and if you store each and every information in the human DNA on a computer, on a file, so that would have all the information like a person's characteristics, what his blood type is, what his cell types are, how his organs are performing, what is the color of his hair, his eyes, his skin, every information about every cell of every organ and every tissue in the body. So that would store, that particular human DNA has all the information about a human being. So that's why you hear about cloning. So for cloning a human being or cloning an animal, just one DNA sample of that human being is good enough to basically clone that living thing. So that is what 1 gigabyte of information would be like. So let's say we zoom another 1,000 times. So from 1 gigabyte, if I zoom another 1,000 times, that would be a terabyte of information. Now, what can we store in a terabyte of information? So let's say you take a handycam, and from the time, let's say a child is born to the time that person gets old, if you capture every single event in the life of that person from the time he's born, for all his events, all his birthdays, all his activities that he does on a daily basis, if you capture that on a handycam, and that would lead to a terabyte of information. So from the time a person is a year old to a person passes away, so that would be like storing information about a terabyte. Now, zooming further, if we zoom another 1,000 times, what you would get is a petabyte. Now you might be thinking that what is this forest, image of this forest that you see on your screen? What has that to do with petabyte? So let's say this image is actually of the Amazon rainforest. I don't know if you guys would have heard or seen movies related to the Amazon rainforest or on Nat Geo. You would have seen documentaries on
Amazon.
Amazon rainforest. Yes, so Amazon rainforest is the world's biggest forest. It is so huge that it passes through the forest covers land areas across many countries in South America. So if you open Google Map and look at Amazon rainforest, you see that it goes through Argentina, it goes to Brazil, it goes through Ecuador, and so many other countries. So it is that huge area of forests with billions and billions of trees. So a data scientist in one of the seminars that I was attending, I was surprised. He was saying that there are 130 hectares of trees, and he was saying that if you chop every tree in this 130, I don't know, millions of hectares of land, if you chop every tree, and if you cut it up and make paper out of all these millions and billions of trees, and then on each and every paper that you produced, if you keep on writing information or if you keep on printing information, then that amount of information that you typed on all those cut trees of paper, that would lead to about 1 petabyte of data. So, and if we have come from petabyte, and if we go further into knowing what an exabyte is, that would be when we actually zoom another 1,000 times from 1 petabyte. That would store the entire information about everything that's happening on Earth, all the people, all the politics, all the trees, all the weather information, people, their skin, their color, their animals, every kind of possible thing, human history, wars, world wars and wars that happened thousands of years back, every kind of information about the Earth, if you store, that would be equated to about 1 exabyte of data. Now, why discussing this kind of volume of data was important is like coming back to the original point. And that original point was human beings, other than the 1 exabyte of information that is already available in natural form, human beings have been able to multiply that by 130 times. And by the year 2005, they were able to create 130 exabytes of information. Now you will ask me, how is it possible? If you look at all the companies, the corporations, the businesses, the IT companies, the non-IT industries, government organizations, non-government organizations, non-profit companies, all these companies over the years, since the information age, let's say in the 80s or the 90s, computer systems have been widely used, they have managed until the year 2005 to create this much information, 130 exabytes of information. It could be call centers, it could be your ERP systems, it could be your sales applications, whatnot. And until 2010, this information has not just multiplied. I don't know what. I mean, you can see until 2010, 1,200 exabytes of information has been created by our IT systems and non-IT systems. And by 2015, this information is again multiplied further. And we have, I think as of today, 8,000 or 9,000 exabytes of data in the system. And they say that by 2020, the amount of information that is generated on a day-to-day basis by various systems and softwares and mobile applications is so huge that we are going to reach about 40,000 exabytes. Now, even on a day-to-day basis, even let's say the impact on individually on us is not that huge, but you can see that just through our cell phones, compared to 10 years back when we were using like ordinary handheld phones like Nokia or any of other devices, maybe in a day we will just use our cell phones to just talk to people or send some text messages to friends. And then probably we will use our computers to look at some information, Google some information. But today, if you see, with all our Android or iPhone or every devices, every minute we are staring at our phones. Every minute we are bombarded with so much of information, whether we are using Google now to check out the latest score, or whether we'll be using some updates that we are getting with the latest information, whether it's weather information or data. So continuously we are bombarded with information. So do you guys agree on this point?
Yes, sir. Yes, sir.
Shiva, does it make sense, the amount of information that we are dealing with?
Yes, absolutely.
Absolutely, right. So this is a very don't you feel this is a very good example in terms of the volume? When I was talking about the volume of information that we are dealing with and the variety of information that we are dealing with on a day-to-day basis is so huge. And the systems today it has come to a stage where this is a analysis that was done by a company called EMC. It was sponsored by EMC. I'm sorry. So they did an analysis to find out what, based on the existing systems and based on the existing hardware and availability of manpower and software and systems, what is it that we can expect by, let's say, the year 2020. So based on the growth of the data and the systems and the information, they analyzed that, like we discussed earlier, around 40,000 exabytes of data is going to be available in systems. But the problem is the companies, they want to use this information to be in the cutting edge of competition. So let's say that if your company is a insurance provider, or if your company is into manufacturing of goods or any kind of services, goods, services, they always want to be on the cutting edge because they want to know what their competitors are doing. They want to be competitive in the market. So they have to use all this data that is available, whether in the form of their own systems, through their customer support applications, through their ERP systems or any other systems, accounting systems. They want to be able to use this variety of information and this humongous set of information to be competitive in the market. Ultimately, that is the purpose of data, right? You guys agree? So Raj, you are talking about the HR information. What you are doing with this HR information? You are using this HR information to provide some information to your managers, who can use this information to make some decisions because they want to grow the business, because they want to be better than the competitors. They want to know before the competitors can know what is going on in the market. So ultimately, that is what is driving businesses crazy, for people like you to be able to analyze this information and give them some insights which they can use to grow in the business and stay on the edge, stay in the competitive edge. So the problem though here is the red line that we see. The red dotted line is the biggest problem, that why you are seeing so much of hype and why the IT industry is creating all these kinds of crazy hype around data science and data scientists. Because there is going to be a huge shortage of data scientists in the coming years, or people like you who are data analysts or business analysts, who can provide solutions. Because as the volume of data grows, there will be more and more systems. Today there could be one single ERP system that is doing all the work for the company. In future, in addition to ERP systems, there could be other systems. It could be websites that are generating a lot of information. Just now I remember Shiva was mentioning about number of hits on the database, right Shiva? So you are talking about the hits on the database. Yes. That you are trying to capture, and you are trying to analyze how many hits are happening on a day-to-day basis.
Yes.
Correct? And the variety of hits and the locations also are probably important, from what areas and regions these hits are coming from.
Yes.
So you want to analyze what we generally call as click stream data, if I'm not mistaken, correct? Sure. It is called click stream. So basically, if you are using a website, then people are clicking on the website, people are using certain features on the website. So that event is a click event.
Yeah, correct.
And capturing of that event is nothing but click stream. I think if I remember, that is a term. So analysis of click stream, what area of the application they clicked on, what was the products they clicked on. Like, let's say, for example, if you Amazon is always capturing this information. So if you have certainly gone and seen in a month, if you have gone to Amazon and clicked on certain products, you will see that on a continuous basis, whenever you open Amazon, and not just Amazon, if you have observed, even when you have gone to, let's say, a news website like news18.com or timesnow.com, you would have observed that the ads that you see on these other websites that are not connected to Amazon also, there you would have seen, because you had clicked on certain products on Amazon, you are seeing those ads in different places not related to Amazon. Can you remember any such scenario that has happened with you guys?
Every day.
Every day you observe that, right?
Yeah, every day. For example,
Yes.
I go to Amazon
Yes.
or Flipkart or Myntra or whatever it is.
Yes.
And what happens is I go to a website where I can download music.
Yeah, totally unrelated, right?
Totally unrelated. Without my knowledge or something, the pop-up comes in saying that okay, fine, you had
Okay.
visited Amazon to purchase what, a hair dryer or purchase a
Yes.
tea, something like that.
Yes. Yes. So this is where the Google Analytics that you were talking about, that you are planning to use in your project, comes into picture, because Amazon uses these Google services.
Correct.
Because without using these Google services, they will not be able to come up with that kind of analytics, and they have partnered with so many other domain hosting organizations, that these domain hosting organizations push these Google ads that Google has recommended to Amazon, so that when they see similar IP addresses, or the similar range of IP addresses, they push these ads into those websites when you call them. You're getting it, how Amazon is intelligently using this, correct?
Similar IP address, they push this advertisements.
Yes, those range. Google might not reveal the full email address, the full IP address, because there are some governance related laws. There could be certain country specific laws. For example, China has a lot of restrictions. You guys are aware, right?
But you can't use Google in China, so yeah.
Yeah. You can use a similar kind of very restricted kind of Google.
Correct.
They will use Google, but everything will look different in that Google. So if somebody opens a map of China in Google, in China, they will see certain parts of India as part. I'm making a controversial statement, but it's a true statement.
Yeah, Arunachal Pradesh is in China.
Yeah. For example, so some other country might observe things differently. So these are all parts of analytics, and how how companies would use. So that is what I wanted to just discuss. Before I could close this slide,
Yes.
so basically, I believe you understood the 4 V's, right? You understood volume, you understood variety, you understood the velocity. Velocity is the most important thing, right? Because if you remember, there are a lot of BI tools that can handle BI, in the sense, when I say BI, business intelligence, right? So like, let's say Cognos, or you would have heard about, I don't know if you would have heard about business objects, or Pentaho, or Crystal reports. You would have heard about a lot of these business intelligence tools that can handle a lot of volume of data, terabytes of data. Even in your organizations that you're working right now, if you talk to your DBA, he will tell, yeah, we have 5 terabytes of data, we have 6 terabytes of data that I'm handling. I don't know, you might have encountered certain database administrators in your company who say, we have so much of data, correct?
Yes.
So the volume of data is one thing, but the velocity at which this data is growing is also a big issue. And systems are failing to handle these kinds of huge sets of data. See, the volume of data is, let's say, for example, currently on your computer, on your hard disk, let's say you have a 1 terabyte hard disk on your computer, or a 500 GB hard disk on your computer. And over the last 5 years, okay, if your laptop is, let's say, 5 years old, on your hard disk over the last 5 years, you would have gathered maybe 20 GB, 30 GB every year. Training materials, work-related materials, emails, movies, whatever you gather, over a period of time, 5 years, you have gathered 20 GB, 50 GB on a yearly basis. And today your hard disk has maybe 250, 300 GB worth of data in 500 GB. But let's say, for example, on a yearly basis, if your data is growing by 500 GB. So today, in this year, you are storing about, on average, every day 5 GB or 10 GB of data you are gathering. And next year, that volume has increased from 500 GB to let's say 1000 GB or 2000 GB, 5000 GB. So you see there's a very sharp trend, right? Very sharp increase in the amount of data information that is being gathered over a period of time, right? Over a period of time, if you are gathering more information compared to what you are gathering previously.
Okay.
So that means the velocity of the gathering of information has increased, right? So it's like a car going at 50 kilometers per hour. Let's say you started from Mumbai to Goa, right? For the first 1 hour of your journey, you were driving at 50 kilometers per hour, right? So in the next 3 hours, you covered 150 kilometers.
Okay.
So maybe from Mumbai, you have reached somewhere in Maharashtra. But next hour of the journey, you have suddenly raised your speed from 50 kilometers to 100 kilometers per hour. So in the next 2 hours, you have covered 200 kilometers. So the velocity at which you have gathered this, covered this area has also increased.
Okay. Yes. Got it.
That is the velocity. So what we were discussing earlier, if you see in the slide, is not the volume. Of course, the volume is huge, but you can see here exponentially the data is growing at a very fast pace, which is the biggest challenge that today's IT systems are handling. Because at a certain point in time, if call centers, let's say your company has call centers, right? Because they have sales people, they have marketing people who are talking to customers and saving information. Earlier, marketing people would collect some basic information, like let's say when they make a marketing pitch to call up some anonymous customers, they collect some information like, you know, what is their annual salary, what is the kind of products they're looking for, what are the products of their interest. Today, if you see, the call centers are even capturing your, when you call up certain call centers, they'll say that, you know, we are capturing your, this message is being recorded for quality purposes. Do you remember? When you make some calls to, let's say, your mobile phone service provider, for quality purposes, this conversation could be recorded. So you are hearing these terms. So for quality purposes, we are recording this information, right? So what are they doing with this recorded information? So they are using analytical tools to understand this information, the data that they are capturing and analyzing this information, right? So the volume of information has increased, the variety of information has increased. See, for example, the quality of data.
Yeah, that means what type of quality, sir? What type of quality actually you want to say? What type of quality?
Say, for example, let's say you are chatting with the let's say if you again take the example of a customer support you know, division, right?
Okay.
So customer support division can have two types. For example, they might be using chat or messenger services to chat with their customers.
Okay.
Another way is through voice, right? Through phone conversations.
Okay.
Now, from a information technology, from a systems point of view, the quality of data that is captured through your chat medium will be of a higher quality compared to information that is captured via a voice medium, because through the voice medium, that information needs to be converted to machine understandable format.
Okay.
Right. For example, if you use Android phone today, if you look at your Android phone, you have an option of talking to Google. Correct. So when you talk to Google, right, using Google Voice, sometimes Google detects whatever you are telling perfectly. Sometimes it does not.
It does not. Right.
Right. So the quality there differs. But if you type it in Google, in the Google help, so Google is able to clearly understand. Whereas if you speak, Google might understand, might not understand. So that's where the quality of information varies.
Right.
Right. Shiva, you also agree on this point? So moving quickly further. Now, data science has these. Now that you guys are in the data science arena, so data science has these three important major areas. The most important area being the computer science area. Now, when I say computer science, it is basically whatever tools, whatever softwares that we'll be using. Let's say we are going to be using R programming or Tableau or any of the other software programs. You might be using database systems, like for example, MySQL or any of the other databases. So those are all part of computer science. So having a very solid foundation of computer science is one of the important aspects of the data science domain. Now, other important aspect is having a sound knowledge of mathematics and statistics. So mathematics, more than mathematics, I would say statistics, because we will cover as part of this course, you will understand why statistics plays a very important role. So because you will be going through various models. So when I say models, these models are mathematical or statistical models. What is the importance of these models? You'll be understanding, because whenever you are dealing with data, you want to pass your data through these models, because these models can then understand your data and bring out some analytical information out of these models. So that's why the role of mathematics and statistics is important. And domain knowledge. Now, both of you belong to, individually, you guys belong to your own, you have your own domains. Like Raj mentioned that he's from a HR domain. Now, Shiva, I'm sorry, I didn't understand which specific domain of business that you deal with. So IT, but your customer or your in-house customer or whatever customer that you're dealing with, they are in a specific domain, right? It could be, you know, what is a specific information technology domain that you're dealing with?
We deal with either IT, HR, finance, or facilities.
Yeah, so basically that is a domain, facilities, HR. So whenever you are analyzing your information, you would have understood that if you, for example, if you are understanding finance very well, or if you are understanding HR very well, HR domain very well, that's when you can really make sense out of what and how to analyze the information, correct? If you don't have very good, let's say, solid foundation in accounting, then finance might be not such an easy field. You might be able to, but you might have a very big learning curve with respect to understanding that. Am I right?
Very true.
Yeah. So these three aspects: computer science, mathematics and statistics, and domain knowledge. So these three, the intersection of these three is what I would call as data science, very simply put. So you might not be master of all these three traits, but having good foundation on these three traits will help you become very good data science executives, or data analysts or business analysts. Moving on to the next slide, the areas of data science. So I had discussed earlier, statistics is one important area of data science. So is data visualization, data mining, database and data processing. So these four areas on the right hand side, this is what our focus is going to be, because these three, the pattern recognition, machine learning and neurocomputing, these are more advanced concepts where you are actually teaching machines to analyze, or what you call it, also you use the word as unsupervised learning. So in unsupervised learning, what happens is you teach the machine what to do, and the machine can forecast and also warn. For example, the warnings, the climate related warnings today in Chennai, right? So there are supercomputers that can analyze the various weather models. So what is the how the cloud formation is, whether these cloud formations can lead to a cyclonic effect. So there are these models which are able to use the data and which are able to observe weather patterns and come up with forecasting, saying that, okay, on the 12th of December 2016 at around 6 p.m. there is going to be a very huge cyclone formation in the Chennai area. So be prepared. So this is basically unsupervised learning, where you have created models, but now you have taught these models to the computers so they can come up with their own predictions. Similarly, tsunami warning systems, or it could be some other systems in big companies, let's say a trading company, where it uses models to understand volatility in the market, correct? So if there are models or algorithms or whatever you might call, if there are models that can understand the data and they're able to predict some kind of volatility in the market, they can warn these stockholders or people who are in the stock market that the computer is observing some kind of volatility due to some changes in patterns in data. So basically that is where unsupervised learning is. And in this course, our focus will be on these four areas: statistics, and then once you do the statistical analysis, how to visualize this data, and also data mining, how to look at patterns in the data. So that is data mining, and also good knowledge about database and data processing, because understanding database systems and how to store and retrieve data, that is also very important part of our course. So in addition to these, there are a few soft skills that are very key. I believe since you both are in this already working in this space, you probably already understand that communication is a very key aspect of your work. See, however good your MIS is, Raj, and however good your analysis is, if you are not able to communicate this to your management in an effective way, in the form of in a very communicative way, whenever you're talking to your stakeholders, your managers, the communication is a very important part. So I believe you guys are already understanding this, and I don't have to explain. The second important aspect is the presentation. Of course, you guys already know, being in your field, that creating a very good presentation and making your information that you have gathered in a form of a very good MIS report or very good kind of a graphical interface, that is very important. So presentation forms a very important part. Domain knowledge, we already discussed about it. And the fourth important aspect that I want to discuss is the real life practice. So now whatever you are learning in this course, you have to put whatever you are learning, plus using all the training materials and all the links that I would provide in the future. So you have to make it into a very good practice for yourself. So you have to spend a lot of time studying R, studying a lot of features in R to master the R, because R by itself, R programming or Tableau, whatever you learn in the future, that is basically an ocean in itself. And more you practice, the better you will be able to perform. So that is what I wanted to mention. So practice is a very important, and some level of programming knowledge. So being able to talk to the computer. So that is what we will be learning as part of the R programming course as well. So having some programming knowledge and programming skills is very important. Now, the final most important thing as part of this course is creativity. So basically, you have to use your creativity to understand data, to creativity to basically present data. So all these above points, they all translate into something beautiful when you are able to use your creativity to understand data in a better way and come up with better predictions to help your business. So that's where you have to use your creative skills. So these were some of the aspects that I wanted to discuss. I will also put this presentation on the shared area, so you guys can actually go through it at a later stage as well. So we can now proceed with whatever we wanted to discuss. So were you guys satisfied with what we went through until now? Just want to get some inputs.
So just let me one thing. What is the general big difference between the data and information?
Yes, I will be coming to that aspect in the coming slides, and I'll also show you some real life examples on difference between data and information. So just give me some time, Raj. So as we proceed, I will discuss that. But until now, what we have covered, based on that, are you getting a gist of what you guys are getting into, or does it excite you to understand the kind of information that we are dealing with in this time?
Yes, Gautam, I just have one thing.
Yeah.
You were talking about, in fact, I have questions on two things. Statistics and programming knowledge. When you say statistics, how much amount of statistical knowledge you want? Because statistics on itself is vast.
Yes, absolutely.
So do we take decisions based on, say, simple p-values, or do we look at some kind of a theorems or ANOVAs to take a decision, or do we deep dive into statistics?
See, for example, from an analyst point of view, observing the p-values, observing the coefficients,
the correlations
those should be all that you should be focused on. In addition to that, in future, if you can pick up on some tools like Tableau, where you can integrate whatever your findings are there in R, and you can use those to provide visualizations. That would be more helpful, Because what happens is, let's say you are working with the set of data, right? And from the set of data, you have taken a sample data out of it. And you have come up with you have understood that, okay, what kind of principles you need to apply on this data, whether you need to go with the linear regression or logistic regression, or even polynomial regression, what not. So once you are able to decipher what kind of model you need to apply, you should then move on to the visualization aspects of it. Because visualization is where you will be able to actually break the ice, because the plots that you will generate, the graphs that you will generate, if they are making visual sense to you, that means that whatever analysis you have done using any of the statistical methods, it is making sense. Let's say, for example, if you came up with a linear regression or a multilinear regression based on a set of data elements, you have to use some kind of method. For example, in statistics, we have something, not just statistics, in analysis, we have something called as backward compatibility or forward compatibility. So if you're working with the 5 or 10 different variables, right, to predict whether this particular data that you have gathered, whether it is making sense, right? For example, in your sales forecasting, what is the impact of the product segmentation, or what is the impact of date, or what is the impact of, let's say, seasonality, right? There could be 5 or 10 different variables that are impacting your result, that is the sales. So if you are able to identify out of the 10 different variables that you have, competitiveness of other companies, for example, that could be another variable. So all these variables, if you can analyze them efficiently using backward compatibility or forward compatibility, and come up with those variables that are really impacting your sales, for example, that is your variable that you are trying to analyze. So then you have hit the nail on the head, because then you have been able to identify which are the variables that are actually affecting my sales target or my profit margins. So the whole process is not actually doing just linear regression or logistic regression, but to be able to understand what are my variables that are impacting my dependent variables.
Okay, so you say that we use a simple equation, y is equal to f of x.
Yes.
So what is my output and what are the factors involving that is affecting my output?
Yes. So basically, if y is equal to f of x is not working, then you will see, okay, then y is equal to f of x plus f1 of x, f2 of x, f3 of x, whatever it is, right? It could be any number of variables. So whether linear regression is fulfilling what I want, or whether I need to look at, polynomial regression, right? So come up with
is there a hard and soft rule that for a problem you have to go step by step? Is there a protocol saying that, okay, fine, if you have a problem X,
okay.
first thing you have to do is you have to do a regression, then you have to do a correlation, blah 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 blah, or just do whatever you want and make sure the output is good?
Yeah, see, what is the advantage of using backward compatibility or forward compatibility is you start playing with, let's say in backward compatibility or backward engineering, they use different terms for that. I would start by using, let's say if I have 10 different variables, I will put in all those 10 different variables to understand how my sales is getting impacted, right? For example, then I observe the p-values and my coefficients, right? Then I will, okay, I see, okay, this has the highest p-value. Okay, I will remove that p-value. Then I will work with my remaining 9 variables. Then I'll see which is my highest p-value. I'll remove the highest, 8, 7, 6, 5. Then I'll see what are the 3 or 4 remaining p-values that will remain at the end. And I will draw some graphs and come up with some visualizations based on that. So then I can show to my management, boss, see, out of these 10 different variables, but I have come up with these 3 or 4 different variables that are actually showing a very good p-value, which is, let's say, below 5% or in the range of 5 to 6%, right? And I have used whatever data you have provided me, the sample data, and I have also tried to apply this sample, the analysis on some of the production data, and I see that the p-values are pretty stable for these 3-4 different values, and I feel these are the factors. Let's say, for example, very low investment on R&D cost is impacting the quality of our product, or very less investment on marketing is in fact having a very high impact on my final profit margin. Okay, so think about investing more on your R&D to reduce your to impact your, so it can impact your profit margin. So that is a better way of looking at it, rather than thinking whether I should apply logistic regression or linear. Okay, logistic regression is completely different because you are dealing with only yes or no kind of answer. But whether to use simple multilinear regression or whether to use polynomial regression, these are all, I feel, it's very silly. Rather than, you should focus on the variables and the p-values.
Yes. So it works again on the same principle, is it? The null and the alternate and stuff like that.
Here again, there is a slide that talks about what is the role of business analytics, right? So business analytics is looking at the past business performance and using the past or the present business performance and being able to give insights into the future. It is a very simple statement to make, but it is not that easy, correct? How can you use the past information, like the past historical information about a company? Let's say for example, if you have the information about the sales information about the last 5 years, or in the HR case, let's say if you have past 5 years information about HR related data, whether it is data related to resources, various skilled resources, unskilled resources, how will you come with the prediction for the future? It's very easy to make that statement, but it is not very straightforward, correct?
Yes.
Because there are a lot of other factors, because 5 years data that is from last year or 2 years back, for that kind of sales target to be achieved, there would have been certain factors like, the business competitors would have been less. But in today's world, maybe there are, instead of 2 or 3 business competitors, you might be dealing with 4 or 5 business competitors or more. Okay. Right? So that is might be driving the profitability down or the sales down. So the variables are very dynamic and they are changing. So it is very easy to say that using past analytics, we can predict the future. But that's why there are statistical models. That's why there is a lot of analysis that is required to come up with the future insights. See, depending on sales is not the only thing. Like profit margin is another thing, right? Or it could be so many other factors. Like if I can give, just now I gave you an example about how much money.
Just let me one thing, sir. Let our company has a good turnover in per year, it is increased, but the retracement is continuing happening. So
sorry, can you repeat that, Raj?
So actually, since 2-3 years, our company has a good turnover. Okay, like 320 crores, then 350 crores, then 400 crores. Like but the retrenchment of employees are continuing happening.
Oh, retention. Like, the retention.
Retention
is. Yeah, so that is slowly going to impact the sales targets in the future, correct? Or the profitability in the future. So what happens is these whatever the tools, like whether we are using R or whether we are using any models will take into consideration the retrievability of the employees in the company. Also as one of the dependent variables for the deriving the profit margins.
Okay.
Right. For example, if there is a lot of attrition, right? If you are losing employees and very critical, so you might then want to divide, when you build your models, you want to divide your employees into, let's say, 3 or 4 categories. One category would be your employees who are related to the marketing area or the sales area. Employees who are in the technical area, who are actually implementing the projects for your customers.
Okay.
Right. The 4th area could be the support staff. Support staff would be staff who are working in the background, people who are generating MIS, people who are taking care of the company, taking care of hiring employees, taking care of firing employees, taking care of so many operational activities in the company. So you will then analyze, okay, out of these 4 categories of employees, which is the category of employee which has the highest impact, right?
Yes.
So basically, you will then analyze that the marketing employees who are actually going and pitching in for customers and getting the new customers, they will be at the second, but they will be at the highest. The second category would be those employees who are actually delivering the projects for your company.
Okay.
Right?
Yes.
And the third could be your operational staff. So first you rank your different kinds of employees. And once you rank them, then you will see what, okay, from let's say from 2014 to 2015, okay, reduction in the marketing people, how it has impacted the profitability in a certain area. So you'll take a sample of data and then you'll analyze whether reducing the number of employees or due to attrition, due to some marketing people leaving the company, how it has impacted the marketing, right? So in how it has impacted the profitability.
Okay.
So first thing is you have to come up with the various dependent and independent variables. So the dependent variables would be these kinds of factors like, attrition, right? They are uncontrollable variables because you can't control them, right? How much attrition is going to happen, or competitors, how many competitors have increased in the market, right? So basically understanding these variables and then using the various statistical models to compare, your dependent variables with your independent variables. That's how you can provide some information to these models, which will then predict, okay, in the future, looking at the basically the attrition. So over a period of time, slowly you have seen that there is been a rise in the attrition. So then the models can predict in the future, okay, how it could impact, right?
Yes, right, sir.
So just to give you an example, real life example. So I want to use just use the Tableau software to give you an example. Are you guys able to see the screen?
Yes, sir.
Okay, so here I have some information. I have information about orders. Okay. So basically, you can see there is an order ID, there is product name. So I just wanted to give a real life example instead of just going through the slides. So here I have some information about orders and I have the various products associated with orders. I have the discount, I have the sales information, I have the profit information, how much quantities were sold. Just you can think about it like an Amazon example, Amazon.com category and subcategory. I also have other information like shipping, when the products were shipped, what is the region, what is the country, what is the customer, what is the date of the order. So I have all this information. Now, this information is not giving me any kind of analytical, knowledge. It is only telling me, okay, I have orders, I have products associated with orders, I have some sales, I have made some profit out of it, etc. Correct? Right. So this is just the data. So if you remember, Raj, you asked me the question, what is the difference between data and information? So this is what you see in front of your eyes is starting from this row, it is data. Okay. And what you see in the header, right? What you call as metadata. This is basically information. Why it is information? Because this is giving me data about data. This is giving me information about my data. Okay. This is telling me that this is order date. Otherwise, if I don't have this column called order date, I don't know what this date is. Right? It could be anything. It could be order date. It could be ship date. Then it could be order requested date. It could be anything. Correct? Yes, sir. So this is the information related to the data. So this is one example. Okay. Correct? Now, if I can show you some graphical information. Okay, so let's say that in the original sheet you had seen that there are some various cities, countries, regions, and then there were some sales figures. Now, what if I can tell you that within using this kind of data, I can just show you a geographical region in a map form, and then just by dragging the sales into it, I can show you what are the regions which records the highest amount of sales. See, this is more meaningful information compared to what you are able to see on the screen here. Am I right?
Okay.
Is it making sense to you, Shiva, as well?
Yes, Gautam, very much.
So the data which is in the raw form, which is very difficult to understand, can be immediately made into something which is very, very understandable, right? Just by visualizing this information. So just by dragging a few times, I have shown that this data is related to some European countries, correct? Because you can see clearly that this has information about Germany, France, Spain, Italy, and also I can see that there are some blue dots and also there are some red dots. So red dots, if you see on the right hand side in the legend, it says that the red ones are in the negative profit, whereas in the blue ones are in the positive. So immediately I can understand that Netherlands is the profit margins are very bad in Netherlands. Even though they are recording sales, the profitability is getting impacted. It could be because of many reasons. It could be because of capital expenditure. It could be because of attrition, like you were saying. A lot of factors could be driving these losses. Whereas other countries are showing decent profitability, and Italy is also showing not very good profitability. With a lighter blue color, I can see that it is also showing some kind of profitability. But then as a manager or as someone in the management, I can immediately call up my sales head or my marketing head in Netherlands and ask him, what is going on? Why is your region not doing good? And then I can help him and fix him or fix the issues that he's facing. Correct?
Yes,
so Raj, to the question that you asked, this is the clear difference between data and information. Correct? So this is what I wanted to show you instead of just going through the slides. Okay. So basically coming to the next slide, this is what we were discussing. Managers interpret the results from the analysis phase, correct? So managers are now able to interpret this information. So if I'm a regional head, I'm able to interpret this information very easily. Correct? So, okay, sorry, I think I skipped some slides. So coming to the next slide. So what are the applications of the business analytics, correct? So we just saw one example. We discussed a few examples earlier where all this can be useful. In this simple scenario, let's say this is related to some company that is selling online products. They are able to use this information to drive their sales and marketing teams to perform better, correct? Similarly, other companies can use this information to in different purposes, like email marketing, right? An email marketing company can use a similar kind of information to come up with various kinds of forecasting, promotions, healthcare, insurance, right? There is not a single field. You are asking me where all it can be used. There is no single field of business where this kind of information is not useful to them. Right? We talked about the customer relation, where customer support, right? They can use both voice data as well as text data to come up with analytics. So you can, for example, if you have heard about like MapReduce in big data terms, they can search for these words that customers are speaking. If they're using angry words or if they're using happy words, so angry words can be, bad performance, or I'm not happy with your support. Or good words can be, I'm very happy with your service that you're providing. I'm really satisfied. So these kinds of terms can be used in an analytical way to understand how customer support is behaving, correct? So financial and marketing activities, we just saw an example of that. Supply chain, you can see whether your goods are moving slowly or whether your goods are moving on time and reaching the customers on time. Human resource planning, we just discussed few examples on that. Pricing decisions. So you can decide how your pricing you want to keep your pricing based on how your sales are. Okay, let me draw a simple example instead of just talking. I thought if I can take another example and show it to you as well. I want to show you an example of forecasting. So I have just taken year of sales and I'm taking sales. So based on this, I want to come up with. So here you can see an example. So this is my current data, correct?
Okay.
So month-wise, year-wise. So basically this is order. Okay, I want to take, okay. So basically I am showing you for the various years from 2011 to 2015. I am showing you the how the sales has progressed. If you see like a trend, right? If I draw a trend line here, so I can see that there is a slow but gradual increase in sales over the period of years. Correct? Are you guys agreeing?
Yes.
The trend line is showing a slow but gradual increase. But if you observe it on a quarterly basis or a monthly basis, you will see that there is a lot of fluctuation. But if you analyze it over a period of time, you can see that it is showing a gradual increase in sales over a period of time. Correct? Are you agreeing, Raj?
Yes, sir.
Now, if I am able to use some forecasting by looking at this data, if I am able to forecast, let's say, in the next couple of years or the next 1 year, how my sales performance is going to be based on these parameters, then don't you think it will be very, very good for the business? So if I say I'll do some forecasting here and say click on forecast. So based on my existing data, I am able to use some inbuilt algorithms or inbuilt logic to forecast my sales based on data from 2011 to 2014. Here, I have been able to forecast my data for 2015. Don't you think it is amazing?
Yes, it is there.
Yeah. So Raj, that is what I wanted to explain. As per the previous one of the slides where they had mentioned that based on the past, you can analyze the future. So this is what I wanted to explain. So that was one of the examples. So can we just proceed for a few more minutes and continue with the content? So importance of business analytics, I think we have understood based on whatever examples that I have quoted, that profitability of business, right? That is what we have seen, one of the examples, and the revenue of the business. These are some of the important factors, and shareholder return. So basically, you can convince your shareholders, right, based on the information. You can enhance the understanding of data. We have seen how we have been able to understand. We have been able to enhance the understanding of our data. Correct? Helps business to remain competitive. Yes, by looking at the data, it becomes very easy for the companies to make decisions. They can see where they are not performing well and where they need to perform better. So understandability and competitiveness increases. So informative reports is anyway that you guys are doing as part of your day-to-day job activities. So you can create reports out of these.
If we were just talking about forecasting, right?
Yes.
We had a data till 2015 and then we forecasted.
2014.
2014.
Yeah.
Based on the average or based on the trend, we decided for the data for 2015.
Yes.
How is it like in statistics? We always look at this terminology that says with 95% confidence, I say that this is how the data is going to be for the next year.
Yes.
Because say for example, we have predicted something,
yes,
and unexpectedly something arises. For example, a demonetization arises.
Yes.
Which happened in the recent past.
Yes.
So every share has gone down. Everything has gone down.
Yes.
So where do we keep? I don't know what is the terminology we use, like the non-functional things.
Yes.
The things we least anticipated or expected. So how do you put all those things in forecasting as well?
See, for example, something like demonetization is something very extreme, extreme measure. You might not, the brilliant of data scientists or data analysts might not have thought about those things, right? But they can take into factor a lot of other. They might have taken into factor a lot of other considerations, like seasonality, and things like how the competitors are behaving. Basically you have to make as part of, like I told you, as part of backward elimination, one of your main aims is to come up with the various factors that can impact your final goals, that is the profitability or the sales, whatever that your final target is. So basically that requires you to analyze all your information and come up with the list of variables that you feel are going to have a very high impact on the business. So I'm pretty sure monetization is something very, very difficult. Demonetization, I'm sorry, is very, very difficult, because nobody would have expected any kind of cash crunch to occur.
Yeah, that's absolutely.
But keeping that one, that factor aside, you can consider a host of dependent variables, right? That could actually impact the profit. I mean, you can think about how much money you are spending on marketing, right? For example, on a monthly basis or on a quarterly basis or on an annual basis.
Yep.
How much of investment is made in R&D? So these are long-term variables, of course, but it of course makes seasonality. For example, if you are talking about US and if you're talking about sales, Black Friday or Christmas, these have seasonality impacts. So you have to take into consideration those variables, and you have to take into consideration other external factors, like if you are dependent on vendors, right? So basically, if they are fulfilling raw goods, so basically based on past performance of vendors, you will see how vendors have been performing during a certain period of time in making sure fulfillment of orders of raw goods, correct? Because that is going to impact your final product that you're going to manufacture, for example. So if you know that you're dealing with vendors who are of high risk nature, you know that there is a risk involved in the completion of the supply of inventory, right? So those kinds of factors will impact your final sales target or whatever the profitability of the company. So all these variables will go into defining the forecast. This was just a simple example where I just used time series, that is the seasonality effect to predict sales. Basically, it used some past data over a period of time without taking into consideration many of the variables, just seasonality, and then it predicted the future. But in your scenarios, you will be using a lot of different variables. I hope I was able to give a short answer. See, ultimately, whom are you developing all these analytics for? It is for your management, right? It is for some human being there who is sitting and analyzing, who is going to look at this and analyze the data, correct?
Yeah.
So he is human. He is not a machine. You are not giving this information to a machine, right?
Yeah.
Let's say, for example, in terms of weather forecasting or tsunami warning systems or things like that, which is very, very risky, right?
Yeah.
So these kinds of systems where the machines are going to make the decisions. Let's say if you think about a scenario where there is a machine floor, right, where manufacturing is happening of, let's say, goods. If the machine is going to manufacture these goods based on the data that you provide, then it is a very high risk where the machine is going to make some forecasting. But in these scenarios, you are providing this information to human beings based on which they are going to come up with the decisions. So management will make a decision, okay, based on the analysis that Shiva has made, we need to start spending more on marketing. We need to reduce our attrition of the marketing guys that has happened over the period of time, which is impacting our sales forecast. So basically, I want to increase my investment on marketing, because clearly it shows that based on Shiva's analysis, this is required. Investment on marketing is required. So those are the decisions that are going to be made. So whereas machines will not make the decisions in these scenarios. So shall I just proceed with the remaining slides? Shiva, was it clear enough?
Yeah, it was.
Yeah. So descriptive analytics, again, we have gone through this. Descriptive analytics, it uses data to understand past and present. So basically we have seen in this graph in the sheet 2. So we have used descriptive analytics to understand the past and present. So in descriptive analytics, we are only going to understand past and present. So here, this is one example where we have used descriptive data to understand the past as well as the present. So basically, we have understood that Netherlands is not doing very good in terms of profit, whereas when looking at the data, it was not understandable. So this is descriptive analytics. Predictive analytics, we have seen one example of predictive analytics where we have seen that how we can use the current and the past data to analyze the future, correct? So this is predictive analytics. Prescriptive analytics, this is where it becomes more complicated. So it uses optimization techniques and suggests what should be done to optimize the result. So this is where we get into the more advanced form, because here we are only telling that this is what it could be based on existing factors. But in prescriptive analytics, you will be telling based on looking at, for example, your dependent variables. What are the variables? What are the factors that could be actually impacting our future performance? So that is where we will be using R and statistical analysis to come up with predictive analysis. Clear?
Right, sir.
So examples, we have already discussed these examples. Retail stores usually run, they have we give an example here, and clearance sales by reducing the prices to price of the goods to finish their inventory. This is a common scenario that you would have observed. So how are they doing this? So they are using descriptive analysis to examine historical data and for similar products, and they'll be using predictive analytics to predict the sales based on the prices, and also they'll be using the prescriptive analytics so to tell, okay, we need to reduce the prices immediately, we need to reduce the prices of certain goods immediately, otherwise we might run the risk of having products sitting in a shelf that have expired, right? This could be very critical in the pharmaceutical industry, correct? So basically where items will expire after a certain date, and it could be very, very hazardous to the life of people also. So healthcare companies will use this kind of information very, it's very important for them. So again, we have discussed this through our examples, data analysis versus statistical analysis. In data analysis, in simple examples, we have seen just by mining the data. So this was a simple case of data analytics where we have just mined the data and we have analyzed it. Okay, what are the regions that are not doing good? What are the regions that are doing extremely good? Whereas in statistical analysis, we have seen an example where we have seen this is basically derived based on a statistical model, what a statistical model can do. So this is where it uses some kind of hypothesis, and it uses some kind of algorithms to come up with the forecasting. Whereas here in data analytics, it just uses visualization, and observes the relationships to come up with the analytics. So this is another thing that we have already discussed. Data is about collecting facts and figures. Database is a collection of computer files containing data. Information comes from analyzing the data. So we have gone through these aspects, correct?
Yes, sir.
Now model, I have discussed a little bit about the models. So basically an abstract or representation of a real system. So what is a model? So basically in this example, we can see that in this case, what a model is doing is, it is analyzing the existing information, and it has created one model by analyzing the various parameters, and when it passes the information saying that show me the data for the future, it uses that model that is created based on existing and past data to come up with a new analysis. So that is what a model is. So it captures the most important features, and then based on that, it uses the mathematical formulas to come up with some kind of meaningful information. So basically you can think about this as a potter, right? A potter is someone who is making earthen pots. So you would have seen that wheel, correct? If you can imagine that scenario, there is this wheel in the middle of the wheel, the potter is holding the clay, right? So he holds and he rotates the wheel. As he rotates the wheel, he uses his hands to model the pot and give it a very beautiful shape, right? So his hands are basically the model, and the wheel is the data. Wheel and the clay is the information, is the data that is moving. So basically he's using his hands to create a very beautiful earthen pot. Correct? That's how you can think about a model as. So the inputs are the data that we have already seen, the uncontrollable variables and the decision variables. So basically there are some uncontrollable variables. So basically here, if we can see what could be an uncontrollable variable. So basically how much quantity is being sold, that is an uncontrollable variable, right? You don't know how much quantity of items are getting sold. Whereas a controllable variable is, you know, your country, your state, your city, the places where you're doing business, the products that you're selling, those are all controllable variables, correct? So when that information is passed to a decision tree, you get the output in the form of a decision. So a decision model is a model used to understand, analyze, or facilitate decision making. So we have already gone through this. Steps in problem solving process, we have gone through it through our examples, but I will just go through it. So recognizing the problem. So that is a very important aspect. So basically when you look at this information, so what is the problem statement? The problem statement is that you want to look at this information, and by looking at this information, you want to be able to predict the sales, the future sales. That is your problem. So that is what is recognizing the problem. So you can look at this in the form of a pyramid. So in the pyramid, at the top of the pyramid, you need to make a problem statement. So the problem statement is, like for example, Shiva was talking. So basically he wants to look at click data in his website, and he wants to know how the revenue can be increased by 15%, let's say on a month-to-month basis. So that is a problem statement. Based on the problem statement, you want to break the problem statement into smaller statements, and then analyze each of those smaller statements and define the variables that can help solve that problem statement. So are you guys able to understand this?
Yes, Knuth.
Yeah. So at the highest level, whatever is the problem statement, I want to analyze my sales data, or I want to my goal, or if it is not problem statement, my goal is to see how I can use the website information, the data captured, click information that is captured in the website, to increase my revenue by 15%. So that is my goal. So then my next step would be to divide that goal into achievable smaller parts. And then each of those small parts, I want to assign them some variables and see whether I can understand these variables that are impacting my goal. So defining the problem, structuring the problem. So here we have structured the problem, and then we are analyzing the problem. So here I am analyzing the problem. It says do specific demographics disappropriately contribute to revenue. Do specific behaviors, these behaviors contribute to revenue. So what are the various factors that are contributing to revenue? And then interpreting the results and making a decision. That we have already seen how we have been able to interpret the results and make a decision. These are some of the steps. All right. Thanks, sir.